As you've probably seen on my website in a few different places, I work at this place called the Technology Showcase on campus at Grand Valley. And our job is to kind of showcase this educational technology to students. We bought previously this robot called the Robomaster EP Core. It's made by DJI and it has a lot of features like mechanism wheels, an arm, a camera and mic, a speaker, and it connects over Wi-Fi to a computer. And then over this connection, you can have it use their simple app that they built for it with a simple user interface to move it around, to have it do things like seeing through the camera that's on board and being able to speak to people in other rooms, which is kind of a fun feature. And this app too allows for like scratch coding and stuff. But what's really cool and powerful about this robot is DJI also made this really convenient software development kit with a lot of functions that are really easy to call and use. And so my task was to create a demonstration that's really fun and uses a lot of the functionality of this robot. I created 3 different programs to kind of showcase what it can do. The first is voice recognition. And so it can respond to voice commands, and it can do things like moving around in different directions. It can dance, which is kind of a fun functionality. And actually, I created like 6 different dances, and it randomly chooses one of them when you tell it to. And then the second program that I wrote for this robot is a following function. So included in the software development kit by Robomaster is some really easy functions to ask it to have a callback. Whenever it detects a person, it runs this function. And what that means is it was not too hard to make it move towards someone if you're far away, or move away from someone if you're up close, and to kind of rotate the robot as the person moves around. And then the final program I created for it is G-code functionality. Since G-code can be used to create like these complex patterns, really my goal with it was to have it draw with chalk on concrete. Unfortunately, just because of the fidelity of the robot and its precision, it doesn't really do that great of a job, but it does still respond to G-code commands and it does still move around. And it doesn't even just do straight lines, which was really easy to create in G-code and have to respond to straight line commands. It actually does arcs as well. The arc functionality is even more limited, and we'll dive into the way the code works a little bit later and kind of give you some overview so you can see it. Jason, go back. Jason, go right. Jason, go right. Jason, dance. Okay, so the next piece of this is that I want to go through and explain all of the code as simply as I can, and I'm going to go pretty quick through it, purely because I don't want this video to be 20 minutes long. No one wants to watch that. Most of this code is really commented out, and not just that, but I posted it both in the sources and extra file that you'll find at the bottom of this webpage, and also on GitHub. And I'll leave a link for that next to the video. But essentially this first piece is the voice recognition that I kind of demoed earlier. And so you can kind of see within this piece of code, I had used a thing called multi-threading. And what that means is that the robot, or not the robot, the computer is switching between tasks really fast because the robot both has to be taking in audio and sending that to the computer. The computer has to then both be receiving that audio and it also has to be turning that audio into speech, into text. That can be then passed into a function that turns that text into commands that the robot runs. And so what that means is that you start 3 tasks, and you'll actually see that right here. So there's the main function, which is going to go into this loop. That's one task. There's this task that receives sound right here, and these are the tasks that creates speech out of that sound. And so these 3 tasks are simultaneously running. It's a little bit buggy to do it in this way, but it essentially is what I was able to do. And also VOSC, which I used as the voice recognition model, which was created, I believe, out of, I think it was MIT that created it. I could be wrong about that. But it essentially is this pretty easy to use library that works offline. And since my computer is connected directly to the robot, it has to work offline. And I couldn't use something more advanced like Google or Apple or whatever service I wanted to do voice recognition through. But besides that, you can kind of see here, it's using this thing called a queue, which is just a way to pass information between different tasks. And it essentially is getting that text in this main function from the queue, and then it turns that text into a command, and that happens right here. And then this run command function, which is right here, it's kind of searching through the text that's provided to see if it's got any relevant commands in it. It loops through this array, and then there's a bunch of different functions that the robot will do. I'm not going to go through them all. There's just way too many. But you can see your basic movement, a bunch of different dance commands. Looks like 7 are listed right here that the robot could choose to do. And that doesn't even include the B-dance, which is a very specific and weird function that I was asked to create. But yeah, you can see a bunch of different, there's just loads of functions that I added in here. Definitely I would love to increase the fidelity of this project in the future, but my coding skills are really, this was really just at the limit of what I was capable of doing. This next piece of code right here, this is about following you around. You can actually access this inside of the voice control. You can ask the robot to follow you and it will. Essentially I use what's called proportional control. It's really simple. I wanted to keep it simple, so that's why I didn't use PD or PID control. And the really, the crux of the way this works is that the software development kit has this method with a callback. And essentially what that does is every time the robot detects a person in the camera, it runs this function called onDetectPerson, and that's right here. And then inside of this function, it's essentially getting the value, the information about where that person is in frame. And then right here, it's getting an approximation as to how far off that is where you want the person to be in frame. And then once it gets that, it has this p-value to kind of put this error value into the correct range. And then the robot is simply driving at a speed in that direction towards you. It's kind of limited. This really only gets so high. And so the robot is pretty slow as you do this. You can increase the p-value and increase the speed the robot's moving, but I wanted it to feel safe for people in the room. And then down here is kind of where you're creating the visual of that. And this was, a lot of this was taken from an example that the Robomaster SDK includes. And then I just really had to add this proportional control bit to make it work. The next piece of code is the G-code command, the third demo that I showed you. So this is the actual piece of code that ran. But what's actually cooler to show off this is kind of some of these visualization pieces I wrote. And so this one in particular, when I run it here, is going to show the robot moving around. It's going to show it running the commands. I created this with a library called Pygame. It's a really common and easy to use Python library for creating simple little games or visualizations like this. So it's kind of perfect. And essentially what that's doing is you have to initialize a bunch of things, and then you have this rectangle, and you also have an image, and you can kind of cover up part of the window with that image. And then kind of similarly, you can do that with text. And so what's happening in this actual code is it's leaping, it is looping through this file, and that's the G-code file. And what it does is each line in that G-code file, it takes and it has this function called, let me find it here, execute. And this execute function essentially finds what kind of command it is. It gets the image to be moved to that position that the G-code is telling you. And it also writes the actual font onto the screen that you kind of see scrolling through. Took a bit to make it work, and I really am, for the sake of time, I'm not going to go too in depth into it. But it's a pretty cool demo, and it only does straight lines. That's the other part of it. I didn't include this really complex class that I'm going to explain next. So that's actually what you'll see here. This code takes forever to run, so I'm just going to start running it and start explaining it. But the reason it takes forever to run is because it's using this library called matplot. And essentially what this allows you to do is to create a plot of a bunch of dots. And each of those dots takes a while to load onto the plot, and then the plot takes itself a while to just load it all in. And what it's doing right now is it's running this really complex G-code file called earthpick, or not, maybe not that complex, but complex in terms of what we're doing. And essentially processes all these commands, and then it creates the plot and kind of puts the dots on it. The really important piece, though, to talk about here is this class I created. This is where it takes these Go2 and Go3 commands, and it essentially gets a bunch of really helpful values for you to interpolate between, or interpolate on the arc of a Go2 or Go3 G-code command. And you'll see that when the plot loads here. Essentially what it's doing is it's getting values like the radius, an angle for the start of the arc from 0 to 360 degrees, and an angle for the end of the arc from 0 to 360 degrees. And then it will get you a target position along each point, or along each angle that you want on that arc. And so then when you can use another function, I use this Go3, this one called Go3. This function is essentially using that class to interpolate along the arc. In practice, the robot really doesn't have enough fidelity to follow an arc very well. You can get it to do it, and you can definitely get it to do simple things like circles, or a couple circles even, but past that, it starts to really struggle. Okay, so what that last piece of code created is an approximation of the shape. So each of these dots that you can kind of see here are essentially target points that the robot would move to. The robot doesn't really have the fidelity to do something this complex, like the Earth. And of course, the image is weirdly compressed because of the scaling of the X and Y axes in this plot. But you can see how the robot would move from point to point, and you can see that the arc class really does a great job of taking these Go2, Go3 commands and turning them into target points. Finally, we get to the piece of code that actually was running on the robot in that demo. And this piece of code really works similar in fashion to both of these. The difference is it's just running on the robot instead of showing you where the robot would move, instead of simulating the robot's motion. One important note is that there is this really helpful method that the software development kit from Robomaster includes, and that's where it allows you to get the robot's best guess as to its position using its inertial measurement unit data that's on board the robot. And so essentially what this callback is doing is every so often, defined by this frequency, so right now it's 20 times a second, it runs this function. And this function right here has these global variables that I put in the code, and they get the position info of the robot. And then I can use that for the rest of the code to kind of determine where the robot should move to based on its best guess as to where it is right now. Working with arcs and working with the weird method I explained, the weird class I created to interpolate in an arc, the fact that you can't actually interpolate with the movement commands, you have to interpolate with speed, which is maybe a little weird to explain, but essentially the robot just really struggles to do arcs, I guess is the point here. And so while I wrote some code that I'm really proud of to kind of help it move in an arc, the robot can't quite do that motion very effectively.